Welcome to lesson 6.5, using proportionality theorems. It is Sunday, 6:36 in the evening, and I have waited till the last minute to do this video. Sorry, I've had a nice weekend, guys. So here we go. We are going to use proportions with a triangle or parallel lines. First, let's review. Give the postulate or theorem that justifies why the triangles are similar. Angle similarity postulate. You could have used this angle, this, and that one. Yes, you could have eventually, if they gave you numbers, found common sides have a proportional relationship, but they gave you no numbers. On number 2, solve the proportion. So 16 times x. I need my calculator. 32 times 12 equals 384 minus 32x. I add 32x to both sides. It should say 32x. And I get, it's Sunday evening and I don't feel like doing math in my head. 48x equals 384. 384 divided by 48 equals 8. Answer is 8. This lesson has a bunch of theorems in it. We learned in the past lesson, chapter 5, about midsegments. And the midsegment theorem, we didn't tell you at the time, but is a special case of the triangle proportionality theorem and its converse. So basically what that says, if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the two sides proportionally. You'll remember that a midsegment is a line that would be parallel to the side, one of the sides of a triangle, and goes through the two midpoints of the other two. So yes, obviously a triangle with a mid-segment going through it, the two triangles would be proportional to each other. The converse of the triangle proportionality theorem is that if a line divides two sides of a triangle proportionally, then it is parallel to the third side. So they want us to find in the diagram QS is parallel to UT. So if they tell us it's parallel, then obviously these are going to be proportional. So if RS is 4 and ST is 6, QU is 9, what is RQ? So they're going to set this up. RQ over QU is proportional to RS over ST. Okay? So RQ is what we're finding. QU is 9. Okay, this is 4, this is 6. Now, yes, the way we've been doing this in class would have actually been 4 over 10 equals Q over Q plus 9. 10x equals 4x plus 36. Subtract x from each side. 6x equals 36. X equals 6. Mathematically, since it's dividing these proportionally, this will work. This would have gone into the idea that the triangles are therefore proportional. So either way to do it will actually work for you. Okay, we're going to also solve a real world problem now. On the shoe rack, AB is 33. BC is 27. CD is 44, and DE is 25. And they want to show you why is the gray shelf not parallel to the floor. So CD to DE, so 44 to 25, okay, and CB is 27 to 33 equals 9 to 11. Obviously, these are not proportional, but the other thing that you could do, this is actually what I would do. 27 over 33 equals 44 over 25. Okay? 27 times 25 equals 675. And 33 times equals 1,452. Since they are not equal, this BD is not parallel to AE. And it kind of talks about that. That found the ratio of each side. I found the ratio of each side cross multiplied. So now guided practice for examples 1 and 2. Find the length of YZ. So what we're saying here is 44 over 35 is going to be proportional to 36 over X, because this is a large triangle, this is the side of one end of the triangle, this is a segment in the triangle. So 44X equals 36 times 35, 1,260 divided by 44, okay, should be 28.63 with a repeating bar notation. Okay, they have 315 divided by 11, which is the same number as we got, 28.63 with a bar notation. Okay, determine whether PS is parallel to QR. If these are parallel, then these should be proportional. So 90 over 50 should be proportional 72 over 40. You could actually simplify this to 9 over 5. I'm going to do that. Just make it a little bit easier. 9 times 40 is going to be 360. 72 times 5 is going to be 360. So yes, PS and QR must be parallel to each other. Theorems, just theorem 6.6 and 6.7, but basically what they say, if 3 parallel lines, so that's line R, S, and T, intersect 2 transversals, then they divide the transversals proportionally. Now be aware, because I know you're going to say, but lines go on forever and ever. And they're talking about these segments. And the same logic would carry through if there were 4 lines, 4 parallel lines, okay, then in the transversal, they would divide them all proportionally. If a ray bisects an angle of a triangle, okay, so it's an angle bisector, then it divides the opposite side into segments whose lengths are proportional to the length of the other 2 sides. So the ratio of AD and DB is going to be proportional to CA and CB. You could actually go back on that projects that we did and look at that, and if you actually drew your angle bisector all the way through, some of you didn't, you can find that number there. So let's use these theorems. In the diagram, angle 1, angle 2, and angle 3 are all congruent. And GF equals 120. DE equals 150. CD is 300. So these are all going to be proportional. So you can set this up many different ways. Okay, corresponding angles are congruent. Okay, so they're all parallel. Use theorem 6, 6. So 150, 300, oh, I can already see that's twice as long. So this is 120. This is going to be 240. Okay. They wanted the difference between Main Street and South Main Street. So this is 240, right? 120 plus 240 is 360. Okay, we could also use theorem 6, 7. In the diagram, QPR is congruent to RPS. So this PR here is an angle bisector. Use given side lengths to find the length of RS. So because PR is the bisector, you can apply theorem. So let RS, we're going to call that X. So this is going to be 15 minus X. So basically 15 minus X to 7 is going to be proportional to X over 13. 15 minus X over 7, X over 13. So 7X equals 15 times 13 is 195 minus 13X. If we add 13X to both sides, we get 20X equals 195. 195 divided by 20 is 9.75. So if this is 9.75, 15 minus 9.75 is 5.25. Okay, so we found X. This was the work that we just did, is 9.75. And obviously the other side would be whatever we'd said, 5.25. Guided practice for lessons 3 and 4. Find the length of AB. So these are proportional. So I'm going to do 15 to 18. It's going to be the same ratio as 16 to line AB, which is X. So 15X equals 16 times 18, that's 288. 288 divided by 15 is 19.2. Okay. So for the next one, they want to find the length of AB. Well, if this is 4 and this is 4 and this is 4 radical 2, then this is going to be 4 radical 2. And here is the daily homework quiz. 20 is 10 are going to be proportional. I can see right away that that's just doubling that. So X is going to be 12. Okay? These are going to be proportional. 12 over 16 is going to equal X over 18. So 12 times 18 is 216 equals 16x. 216 divided by 16 is going to be 13.5. In problem number 3, find the value of the variable. Now, they tell us there that angle 1 is congruent to angle 2, so this is an angle bisector. So 17 over 10 is going to be congruent to y over 14. 10y equals 17 times 14 is 238, divided by 10 is 23.8. And the diagram represents a tract of land being developed for homes. Which lot has the greatest perimeter? So this is going to be 80. So let's find the perimeter of each one. Lot A is going to be 80 plus 130 plus 85 plus 110. And that's 405. That's A. Okay. Lot B, we do not know the length here, but we know that these are going to be the same relationship. So we know that 80 over 120, which I'm actually going to just simplify right now to 8 over 12. I could simplify that further, but I'll at least cut some numbers out for me, is going to be proportional to 85 over x. So 12 times 85 is 1020 divided by 8 is going to be 127.5. So this is going to be 120 plus 110 plus 127.5 plus 80 is 437.5 for B. Now for C, I could use proportions again, or I could say I started it with this whole length as a 400. I subtracted 85 for lot A. I subtracted 127.5 for lot B. So lot C is 187.5 plus 45 plus 150 plus 80, 462. So lot C has the greatest perimeter. And here are the problems that your homework comes from. We'll do constructions in class this week. We'll do that construction.